Hey guys, today you're going to start your GIZMO or online simulation with distance time graphs. So the whole point today is to get you guys familiar with distance time graphs. I know you've been going over it, but I want to make sure that we hit this perfectly good so we are good to go. So there's a couple things you need to know. One screen, so nice and easy today, not multiple tabs, just one tab that we're going to work with so we don't have to click back and forth between screens or use each other's computers to help. So let's get familiar with this. My distance time graph is going to be over here on the right. Again, we have time on the bottom and distance on the side here. The exact same as everything we've done. Up here, we have number of points. So this is number of points on the graph. So as you can see, I have two dots here, 1, 2. I have 2 points on the graph. If I move this up number of points, now this gives me 6 number of points. So 1, 2, 3, 4, 5, 6. So there's 6 points where I can change the speed or the distance of my runner or my person. Now, it will always mark those evenly spaced. So if I do 10, it will have them evenly spaced. If I do 2, it will have them evenly spaced. Next, down below it, you have runner 1, which is who we see. You can show the graph for runner 1. You can show the animation. I would always keep those on if I were you guys. The graph is what you're going to see on the right. The animation is the person that you're going to see on the bottom. Now, you do have that for one person. You can also do that for 2 people. So we also have a blue person that we can show the graph and show the animation. Now, you can click new and it'll randomize it for you guys. I don't think we technically need to do that or worry about that right now. Okay, other things that we need to see or look at. Down here is our animation for the person running. They're starting at 0. There's 10 yards, 20 yards, 30 yards, and 40 yards. And then I have a stopwatch. The green means go. The red means stop. So if I hit green, the person is going to run. When I hit stop, it's actually going to reset. So this is a little tricky because I can't pause it. So what you have to do if you want the person to stop at 20 yards, you will actually have to take and move your green cursor back and forth to move the person where you need them to go. Right. So let's talk about distance time graphs real quick and what we're looking at. So as I can see right here, my distance time graph is starting at 0, 0. So 0 time, 0 distance, which means my person is facing from left to right. So they're on the left of my screen, they're facing to the right. When I hit go, it's going to show that my person is continually going forward because my graph or my line is going from the bottom left to the top right. And that shows us moving in a positive manner or positive distances. It means we are always moving forward. Remember, if I have my line going straight across, that means my person does not move. Okay, so if I hit go here, my person is going to stay the same because my line is straight across or parallel to my time, which means they're not moving. And if we go the opposite of our first simulation, we are going starting. Let's start at 20. Actually, let's start at 30. Going from 30 to 0, now I'm going from the top left to the bottom right, which means my person is moving backwards. Okay, so they are running backwards. So remember the thing that I always like to talk about. Let me do 4 points here. I am going forward, I am staying the same, and then I'm going backwards. So I'm going to run forward, I'm going to stay the same for a second or two, and then I'm going to go backwards. So let's see what that looks like. So go forward, stay the same. Now I'm going to go back. That's what it looks like on the graph. So once you guys get into all of this, we will work on a, there we go. We'll work on a couple of different races. So if I want to look at a race, let's say I want to start this person at 40 and I want them to go, I want them to both meet in the middle. That means my red person is going left to right. They're going forward. My blue person is going right to left. They're going backwards. So if I click it, they should get there. They should both stop at 20. But let's say I want to see what it looks like when the blue person is at 1 second. Remember, I need to drag my green bar back and forth here to see where they are. Later on in this project, you guys are going to see some fun scenarios that they're going to ask you to do. Like, hey, the blue person is a cop or the red person is a cop, the other person is a purse snatcher. If the blue person starts at 10 yards, how long will it take the red person to catch them to get to 40? And they'll give you guys specific speeds to go at. Please remember on this, speed equals distance over time. We can write that as a fraction. We can write that as a division problem. I would recommend writing it as a fraction. So speed equals distance over time. Make sure our distance has a unit of measurement. So in this case, we are using yards. And always make sure that our time has a unit of measurement. So here we are using seconds. So any speed that we use for this project is going to be yards per second. Okay, there's no miles, there's no hours, there's no second or no minutes. It is yards per second. I think that is all for this. I want you guys to have fun with this, but I also want you to make sure you're paying attention to this distance time graph. Those are hard for fifth grade kids to comprehend or understand fully. So that's why we're spending so much time on them. Hopefully, this goes well. I will see you guys soon.